So welcome to this session of data analytics by OpenMentor. Last class we have seen parameters passing to the functions and then calling the function with multiple parameters. Today I'm going to introduce some more variant of the function. Okay, let me define a function F100. Okay, and then last class we have done as for example R comma H. So I'm going to calculate the volume of a cylinder. Okay, wall equal to 22 by 7 star R star R star H pi R squared H. Correct. Print F100. Then I'm printing the value of wall. Okay, so this is a function, or say let me say FV function volume pi R squared H is the volume of a cylinder. Now I'm going to call it, for example, FV of 10, 4. Okay, FV of 5, 6. Okay, now I'm also going to print something over here. Print R equal to comma R. What is the value that is being passed? Print H equal to 10, H. So I'm printing those two also for our purpose. Let me run it. It's a simple function. I am calling 10, 4. R becomes 10. H becomes 4. Then R, when I call 5, 6, R becomes 5. H becomes 6. And it is calculating the value. Very simple, right? No problem. Now, I want to say height is, right now, if I don't define anything, 10 goes to the first parameter, 4 goes to the second parameter. Instead, I want to say, okay, let me give you FV 5, 6. Then I'm going to call FV H is equal to 5, R is equal to 6. So I'm calling like this. If I don't specify anything, 5 will go to R, 6 will go to H. But I'm specifically saying H is equal to 5, R is equal to 6. So you can give the parameter name equal to what is the value. You can call that way also. Now look at the way. If I send 5 and 6, the volume is 471. If I send 6 and 5, the volume is 565. So this is another way of calling. This is called name of param and value. So this is called name value. So you send the name equal to value. So this is one way of, another way of calling the functions. Reason why we need this is when there are at least 5, 6 parameters or even 10 parameters in some function. By mistake, we call it in the wrong order, then our calculations will go wrong. Instead of getting into that kind of a bad situation, people can always say, this is my parameter name, this is the value, so that there is no question of having a wrong value. Is this clear to you all? Calling by name and the value, so that there is absolutely, even if I interchange the order, I will not have any problems. The next thing I want to say, I say FV, 7. I forgot the second parameter. Let me run it. The moment I run it, it is getting into a problem saying that, hey, you have a problem here because this thing is the value, you have not passed H. So it is giving an error in this line because I didn't pass H. So if if I don't want to miss something, right, then all I need to do is very simple. The way I can do that is, if by mistake, if somebody misses a parameter from passing, if somebody did not pass R, keep it as 1. If somebody did not pass H, then keep it as 1. So this is like, if not passed, what should I do? I think the other day somebody asked a default something like that. So if the parameter was not passed, what value I should assume? That you will give it in the declaration itself. So now if I explicitly pass, R will be 10, H will be 4. I explicitly pass a value, it will take that. But if in this case I passed R, but I did not pass H, see what will happen. See, R I passed as 7, H I did not pass. So it took 1 as the value and then it printed the value as 154. So this is called a default value, or I would say very simple way, if not passed, assume this value for the param. Is this concept clear? Very simple concepts. Very simple concepts, but very powerful in Python. Very simple. Syntax is also very simple. No way we can make mistakes. See, right now, what we are doing in this thing is, the notation we are calling is f of volume, or say for example, f of r comma h is the volume. This is the mathematical notation. A function of r and h becomes the volume. So I am using this notation. I am not using the notation of y is equal to f of x or v is equal to function r of h. If I want to do that way, all I need to do is, let me just copy, we create one more code section. Now, if I want to use that notation, what should I do? I want to say, rather than printing here, let me do, I have to use a return, okay, a return statement. Now, let me say x is equal to fv of 5, 6, print x. So this is the mathematical notation of y is equal to, or say v is equal to function of r comma h. This is the mathematical notation. That means this is also mathematical notation. In this, there is no left hand side, right hand side. Everything is parameters. Here, there's a left hand side, there's an equal to, there's a right hand side. Okay. So this is also another, most of the times we have formulas like this only, left hand side equal to right hand side. The only difference between this and this is the return statement. Now let me execute this one. I passed r is equal to 5, h is equal to 6, it calculated pi r squared h, then it returned val, that value got assigned to x. Okay. So this is a very specific notation in terms of, for example, I do like this. Let me try to call this way, see what happens. fv of 5, 6. Okay. Now also it sent 471, but it returned a value to the console to printing. It didn't assign it to any variable. So if you don't assign it to variable, it will just print it on the console, but you cannot use somewhere else for further processing. So if at all you want to have a further processing, you need, if you want to use the returned value, then you need to use a variable so that this value gets returned and then stored in this variable, and then you proceed further. The only statement difference is return. In some programming languages, no return means procedure. People call it as procedure. Return means function. So the terminology that people may use is, if there is no return value, there is no L, it is not sending something to the LHS. That means it is a procedure. If it is sending something to the LHS, it is called function. The only difference is return. So the variant that you see today in functions is, you give, if the parameter is not passed, what value I should assume. That is one difference that we saw. Then calling the function with named parameters, name equal to value, so that I can interchange, or the position doesn't matter. That is the second thing that we saw. Then the third thing that we saw is LHS equal to function, so that it returns a value, it gets stored to the variable. After executing the function, it returns this. So these are all the variants of procedures and functions and parameters. Is this concept clear to you all? Any rocket science in this? Even for people who are out of touch from programming or non-computer science students, do you see any issues? If you see any issues, just raise your hands. Very simple, straightforward, no unwanted, clumsy or confusing syntax. Good. Now, I'm going to show one more thing as part of functions, significance of functions. Okay. Now, I'm going to use two different procedures. Okay. Let me say procedures. Def P1, colon, print P1. Okay. I'm going to say A is equal to 0, print A. Okay. This is one function. Now I want to have one more function. What is that function? Same, let me copy paste. P2. I am going to create a P2, another, but I am going to use the same variable A. Let me, instead of 10, I say 10, 0, 10, 20. Now, so there is one procedure P1, then there is another procedure P2. In both, I have used the same name as A as variable. Now I am going to use one more variable outside these functions. A is equal to 99. Print outside is equal to A. Okay. Now I am going to say P1, call P2, then print outside A. What I am doing, the same variable A appears inside P1, inside P2, outside P1 and P2. Now let me execute the whole code. If you look here, outside is, I have initiated to 99, so it is printing outside 99. I am calling P1, inside that I have defined it as 10, so it is printing 10. I come to P2, I assigned it to 20, it is printing 20. It finished P2, it came out, but it printed 99. First it was 99, then I assigned it as 10, then I assigned it as 20, but even after coming out of P2, it was not retaining the value 20. Instead, it printed 99, whatever I have defined here. This This concept is called scope. This concept is called scope. Anything inside a function you defined, it is called local scope. Anything inside a function you declare a variable, that variable will be inside that. Anything outside you say, it is called global scope. Though the name of the variable is exactly the same, this A is different, this A is different, this A is different. Any change here will affect only P1. Any change here of A will affect P2. The moment I come out of P1 and P2, I retain this value. Okay? This is like state 1, this is like state 2, this is like central government. Okay? Global is like central government, local is like a state government. So even though I made a change inside it, this A is equal to 20 did not affect anything that I did over here. So while coming out of P2, it was still retaining the value of 99. This is because the scope of A is, this A is limited to P2. The scope of this A is limited to P1. Is this clear? The scope meaning if it is defined inside the function, it is local. It is defined outside all the functions, it is global. Very simple. Local variables or local scope always get created, and the moment I enter line 2 or line 1, the A gets created. The moment I exit line 4, this A is gone. The moment, this is like a triple action of A. This A is different, this A is different, this A is different. Now I am going to show you one more thing. What I am going to show is this A is 20. Okay. This A is 10. Now I am going to say by the moment I declare a variable like here, he takes local scope. Now I am going to purposefully say, okay, just watch. I am going to use a keyword global. I am going to say global A. I am not using global A here. I am going to say whenever you see a variable A inside this P1, do not create a new one locally. Okay. The moment I use global A, it takes this A and this A as same. So for that, to instruct P1, do not create a new local variable, use the global variable itself. If you have to say that way, you have to explicitly say global and then the variable name. Now what will happen? Here it is 99. I go inside. It says global A. The moment I say 10, so this variable also get changed to 10. Now I come to P2. Now I say A20. This A becomes local. This is not. Now the moment I come out of this, see what is the value it prints. Now let me run it. So initially it is outside, it is 99. Okay. Now I call P1, it goes here, it is global A, it assigned to A is equal to 10, inside P1 it is printing 10. Then it goes to P2, it says A20, it creates a local variable A20. It exits P2, the moment I say, what is the value of A? It says 10 because in P1, you altered the value of this. From 99 to 10 you altered. So the change reflects here. But the change, since you did not mention this is global, this is a local variable, this A is a global variable. So this is called scope. Scope meaning within my territory, I will have one flavor, one face. Outside my territory, I will have another face. So I have two different faces, local face and global face. Global face is common to all the functions provided you explicitly use the keyword global. If you do not mention the keyword global, he will create a new local variable of the same name. The moment the function is exited, he will destroy that local copy. Global comes into effect after that. Is the scope clear to you all? Again, a very simple concept. To differentiate, you have to use global or local. Is this clear? Good. Again, the way these Python guys have done is very simple keywords and very English-like, much better than Java also, so that we are very, very little chance to make issues or errors. Now, if you really look at what we have seen so far, a lot of things that we have covered today. The scope of variables we covered. We also on local, global we covered. Calling by name we covered. Default value of the parameters we covered. And then the way that you can alter the variables through the keywords we have seen. So with that, I am going to stop the session for the day, but I'm going to give you a case study for you.